Okay, 15F, still on confidence intervals. This question looks at where we're finding our sample size. It's example 16, and it says, consider again the problem of estimating the average IQ for Year 12 mathematics students in Australia. What sample size is required to ensure the margin of error is 1.5 points, more or less, of the 95% confidence level, assuming that standard deviation is 15. Now, when we refer to margin of error, we're referring to this, because in our normal distribution, this is where our mean sits in the middle, and we're looking how far we're going that way and how far we're going that way to get our confidence interval. So the setup is, with margin of error being 1.5, that's Z then equals 1.5. Notice for a question like this, we do not need to know the mean. So there doesn't need to be any mention of what the mean is. We need to know the Z, so that's for the relevant confidence interval. It's a 95% confidence interval, so Z is 1.96. We need to know the standard deviation. Excuse me. So this is 1.96 times 15 over the square root of n equals 1.5. Now, we can solve that easily using our algebra. So we can go down, I would go 1.96 times 15 over 1.5 equals square root of n. Just bring in the 1.5 down and point square root of n over. And then 1.96 times 15 over 1.5 squared is going to be my n. Solve that out that way, nice and easy. The other option is, from that point you can do solve n and just pop that into solve n. I'll show you how to do that. If we go options, calculate, bring that down to C. I'm going to go solve, oh, excuse me, I just deleted something there. Solve n. And if I put in directly 1.96 times 15 over shift square root x, because that's what I'm trying to find. Obviously my calculator doesn't do an n. Bring it back up, equals, shift dot gives me my equals, 1.5, close my brackets, solve, and it gives me 9,604 on 25. Well, that's not very helpful. There we go. N equals 384.16. Now, we cannot have 0.16 of a person. I want you to always round up. So sample size 385 is the minimum sample size needed to achieve the margin of error of at most 1.5 on a 95%. Okay, always remembering to round up. And there we're done. We've calculated n.